A leading magazine, like Barron's, reported at one time that the average number of weeks an individual is unemployed is 37.1 weeks. Assume that for the population of all unemployed individuals, the population mean length of unemployment is 37.1 weeks, and that the population standard deviation is 8.3 weeks. Suppose that you would like to select a random sample of 59 unemployed individuals for a follow-up study. First, we'll call this part A. Let's find the probability that a single randomly selected value is between 34 and 35.3 for the average. So let's see. For the first one, to find the probability that a single selected value is between 34 and 35.3, we're going to do the probability that a single randomly selected value is less than 35.3 weeks and subtract off the probability that a single value is less than 34 weeks. Just to give you a picture of why we do it that way, if we have our normal distribution curve, and in the middle is the mean, 37.1, then let's see, probability that x is less than 35.3, so let's say this is for 35.3, that would be this probability, and I'll change colors here to light green. Let's see, the probability that x is less than 34 would be to the area to the left of 34 here. If we subtract off this green area from the large red total, then what we get is this area in the middle, which is the probability between 34 and 35.3. Okay, so here we go. First probability, the probability that a randomly chosen individual has a average number of weeks of unemployment less than 35.3. So what we're going to do is because this is not a standard normal distribution, it's just a normal distribution. So we need to find the corresponding z-score. So we're going to use our random variable minus our mean divided by the standard deviation. Now in part A, we don't have a smaller sample size, so we can simply use let's see, the 35.3 minus the mean, which was 37.1, divided by the standard deviation of 8.3. And let's see, when we plug that into our calculators, bear with me, we should get negative 0.2168. Well, z-scores don't get that specific, so let's approximate negative 0.22. Okay, let's find the probability corresponding to that z-score. So negative 0.22 for that z-score. So let me go over here to my negative z probability table, and let me get out my little pointer. 0.22. So 0.2 is down here, and then the second decimal place being 2 is in the third column over, so right here. So this 4129 is what I'm going to use. Of course, you can use your calculators like your TI 83s and 84s to get a better approximation. I'm going to use the table just in case you folks don't have a nice calculator. So 4129, the probability that our variable is less than 35.3 is 0.4129. Okay, on to this one. Let's see, the probability that x is less than 34. So let's do same thing. 34 minus 37.1 over 8.3. And when we plug this into the calculator, we get a negative 0.373. Well, z-scores again don't get that close, so let's just do negative 0.37. And going back to my probability table, 0.3 7 be over here, 0.3557. So this is the one we're going to pick. Okay, so that was probability that x was less than 34 was 0.3557. Okay, and remember we're going to subtract those two. So 0.4129 minus 0.3557 gives us 0.4129 minus 0.3557, 0.0572. Now, this is an approximate probability because I had to approximate with my probability table for the z-scores on the next page. But if you're not using a calculator, this is a pretty good estimate of that probability. If you are using a calculator, you'll get something different. When I used my calculator, I got 0.0598. So 0.0598, pretty close to our 0.0572. Okay, let's do part B because I really want to show you how they're different. So in part B, we have the same kind of question. Find the probability that a sample size n equals 59 this time is randomly selected and that sample has a mean between 34 and 35.3. So now we're finding the probability that a smaller sample has the same mean between 34 and 35.3. So all this stuff we did up here is going to be really, really similar. The big difference is when we're finding our standard deviation, we're going to need to divide by the square root of our sample size. So we're still going to do the probability that x bar is less than 35.3 and subtract the probability that x bar is less than 34. And I'm using x bar because now we're talking about a smaller sample. But when we calculate our z-scores, we're going to do x minus, now remember, mu sub x bar, the sample mean is equivalent to the population mean. And sigma sub x bar is equal to, so this is equal to mu, sigma divided by the square root of n. So the z-score here for the first one will be 35.3, still minus 37.1, but now we're going to divide by 8.3 divided by the square root of, what was it, 59? 59. And this time we get a z-score much different than the previous, negative 1.67. Okay, the probability associated with that, negative 1.67, let's go back over here. So here's a little negative 1.6, 1.67 will take us here, 0.0475. 0.0475. Let's ignore these guys. Okay, so that had a probability x bar is less than 35.3, 0.0475. Okay, let's do this guy. The z-score here is going to be x bar minus mu over sigma divided by the square root of n also. So 34 minus 37.1 divided by 8.3 over the square root of 59. And this z-value gives us negative 2.869. Very, very different than the last one. So we're going to do about negative 2.87. We go back over to our other table. Let's see, negative 2. What was that? 87. So 2.8. Negative 0.0021 here. So So our probability that x bar is less than 34 is 0.0021. And just like in the last one, we take the previous probability and the current probability and we subtract them. So 0.0475 minus 0.0021 to get 0.0475 minus 0.0021 to get 0.0454. Whoops, forgot a zero. Oh boy. Let's go smaller. There we go. This is 0.0454. So this one should be 0.0454, and for the previous one, 0.0572.